Hi, welcome. In this video, we'll be talking about how a computer works. We'll look at the different components that helps the computer to execute code. We're not going to look at everything in detail, but we'll look at it from the software point of view. So let's take a look. So the first one we are going to be talking about is the disk. Disk here. All right. So the disk is also known as the storage of the computer. This disk helps the computer to store data persistently. So we have a file here that a user created on their computer here. So when this file is saved onto the disk, whatever happens to this computer later on will not affect the file stored in the disk. Let's look at a scenario. Let's say, for instance, I have a computer C1. A computer C1 here. C1 is this computer here that has disk B1, and another computer C2 here, C2 that has disk B2. So when the C1 computer here crashes, we can still take the D1, which is the disk 1 of this computer 1, and use it in this computer C2 here. So we can move this disk into this computer and still be able to read whatever data was stored into this computer, into this disk 1. So whatever happens to the computer does not affect the disk. When the computer is turned off, for instance, the file saved onto the disk can always be retrieved whenever the computer is turned back on. And disks are usually in size of gigabytes or terabytes sometimes. The unit measure of computers is bits. 1 byte is equal to 8 bits. And these 8 bits are usually zeros and ones. 8 of them, zeros and so the computer understands details or letters in binary form. The letter A, for instance, although this is not an accurate explanation when it comes to binary, how the computer reads the letter A. But the letter A, for instance, can be compiled down and be read by the computer as 0, 0, 1, 1, or 0, 1, 1, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, the last one was not needed. All right. So that's it basically. So the disk here, this disk here, this disk here helps the computer store data persistently. That's its job. Now, the second component we have here is the RAM. The RAM stands for random access memory. It is the memory of the computer. The RAM is a lot faster than the disk in terms of storing, data into memory. But the RAM is a lot more expensive than the disk. The RAM, compared to the disk, usually comes in smaller size due to how expensive it is. And the minimum RAM a computer can have is 2 gig. I've not seen any computer with a 2 gig RAM before, but the least I've seen is 4 gig. And this size can go up depending on the resource needed for this computer to work. You can have, currently my computer has a 16 gig RAM. So you can have computers with 32 gig RAM and so on. So compared to the disk, let me make a quick comparison between the RAM and the disk. So both of them store data, but the RAM is a lot more faster than the disk. So the RAM is faster than the disk, but it's a lot more expensive than the disk hardware. So the RAM is just expensive. It's more expensive than the disk. But the disk does something which is quite different from how the RAM operates. The disk stores data persistently, but data stored in the RAM are immediately lost when the computer is shut down. So the RAM does not store data persistently compared to the disk that stores data persistently. And let's not confuse the RAM with a ROM. These are two different things. Sorry. The RAM is random access memory, whereas the ROM is the read-only memory. What does the ROM do? The ROM contains sets of instructions used by the computer itself to do do other things, such as bootstrapping the the computer. Let's say when you turn on your computer, for instance, when the switch of your the computer is turned on, you don't see the screen coming up immediately. So within that split second, what the computer does is it goes to the ROM, and gets the instructions on how to boot up the computer. Then it reads those instructions, then allows the computer to boot or to display some errors depending on the state of your computer. So that's the difference between the RAM and ROM. RAM stands for random access memory, and ROM is the read-only memory. Now, so we just looked at, the disk and the RAM. So we've been talking about how they store data, but something is very important to know, because once we store data, we need to read the data. So let's take a look. Let me draw so we have the RAM here, which stores data, and the disk here, which also stores data, but does that persistently. Now, for the computer to be able to read data stored on the RAM and the disk, we need a third component, which is the CPU. That is quite bold. So the CPU reads data from and reads data from, and writes data to both disk and RAM, both RAM and disk. So the data read in this two components is possible through the CPU. So this is what um, facilitates that process. The CPU facilitates the process. But let's take a look at the RAM, for instance. When we write code on our computer, when we write code on our computer, when we write code on our let me use white one. When we write code on our computer, let's say we have code here, it is stored in the RAM. So our code is here. So that code would then be read by the CPU and executed from the RAM by the CPU. But the CPU also has another component called the cache. This cache is usually in size of megabytes, not that big, which helps the CPU to even read data from this RAM much more faster than it normally does on its own. So how does this happen? So let's see there's an operation that goes on over and over again. So a repeated task in the RAM or in our code. For instance, we have variable names. Let's say we store a variable x, which is equal to 10. So this variable here will remain a variable. So this is not a repeated task that our program will be doing. But something like a loop, for instance, can happen within our program over and over again. So this variable here will be then stored in the cache for the CPU to retrieve it easily, so that it doesn't go back to the to the RAM to get the variable every time. But something like the loop, for instance, will be stored in the RAM always and not inside the cache for the CPU to read it. So it will always exist in the RAM, and the CPU will always go back to the RAM to get that value. So that's it for this brief overview on the different components that come into play when when our program is trying to execute a code. So we talked about the disk being a persistent storage for the computer, and also we looked at the RAM, which is the random access memory, which is very volatile. It does not store data persistently as compared to the disk, but then it is faster than the disk in terms of storage and retrieval of data. And also we looked at the difference between the RAM and ROM, not to confuse them anytime. And we look at how the CPU reads data from the RAM and the disk. And the kind of data we looked at is how the CPU executes our code, our program. All right, that's it for this video. Thanks for watching.